In the PAROMA MED project, the University of Rennes implements a use case dedicated to medical image analysis. Artificial intelligence in medical field plays a central role in modern healthcare and has demonstrated good performance with deep learning. As of today, we commonly use what we call centralized learning, which consists of training the AI model using reference data. As we can see on the right side, these data are collected from one or several hospitals and stored on a local hardware. That scheme introduces security issues, in particular with regard to data collection, since it requires to transmit highly sensitive data.
Federated learning allows to address these issues. Instead of moving the data, it is the model which is transmitted during the training phase. Local models are then trained in the hospital domains before being aggregated in a central node. This process is performed in a loop to improve the quality of the model. As a use case, we focus on hard segmentation, which consists of associating a label to each pixel in the input image. These input images are CT scans and contain 5 structures: myocardium, left and right ventricle, left atrium, and aorta. From these segmentations, we measure the thickness of the myocardium in green in both images, which is an important value for diagnosis and treatment planning. This process relies on the PAROMA MED platform. Data processing and model training take place inside the hospitals, and once the final model is obtained, it can be used on a new image in order to compute the myocardium thickness. In order to assess the final model's performance, we use the dye score, which is a measure of the geometric correspondence between the reference delineation and the segmentation. That score varies from 0 to 1, with 1 being a perfect match. Comparing standard centralized learning with federated learning, as done in the PAROMA MED project, we show that we can achieve equivalent performance without moving the patient data, thus guaranteeing its privacy.